Jeremy, you're muted.
That's the best way to kick off a show is just read my lips. I'm muted. But welcome to another episode of the Entity Framework Core Community Stand-Up. Super excited today. We are going to go through a few community links, and then we're going to dive right in. I'm here with Shai. Shai, say hello.
Hello, everybody. I'm Shai I'm an engineer on the If Core team. I do a lot of work on Postgres and on performance and on the basic database APIs of .NET.
And then we have our special guest, Michael, with Chili Cream, who is the author of Hot Chocolate and Strawberry Shake. Welcome, yes. Michael.
Hi, everyone.
All right. My name is Jeremy Lickness. I'm a PM for .NET Data. And I'm going to go ahead and pull up some of our community links real quick. These are our links. And the first link, actually, let me show you the URL for this. So as always, you can find all of our links at the URL list. This is the stand-up for 5/19. And the first link was an interview that InfoQ did with me on Entity Framework Core. If you're interested in some of the philosophies behind EF Core and a little bit of what's happening, check that out. The next link that we'll cover is the release of John P. Smith's Entity Framework Core in Action. So this is the second edition. It's very current, covers, I believe, EF Core 5 in full. So excited about that release. Congratulations to John for that. The other thing I won't spend too much time on, but if you are interested in Azure Cosmos DB and Entity Framework Core, I built a reference application. This was for the Azure Cosmos DB conference. And this is a full create, read, update, delete application written in Blazor server that uses the Entity Framework Core provider to talk to Azure Cosmos DB. This article, which says it's a 26-minute read, it may take longer or shorter depending on your style, but it goes into a very deep dive into the philosophy behind all of the code in that repository. So check that out. And then last but not least, we've got the link to the repo for Hot Chocolate. And I'm not going to spend too much time on that because that is why our guest, Michael, is here. So without further ado, I am going to remove my share from the screen and turn it over to Michael.
Yeah, hi everyone. I think we can have a lot of fun with Entity Framework and Hot Chocolate today. So I brought the first real usable bits of version 12, which is coming out in end of June. And it has a much better integration now with Entity Framework. It makes it really fun to use. So in order to get a bit into GraphQL, because maybe not everyone here knows GraphQL that well, let's have a look at a very basic example to just get started. And in this example, we don't use any entity framework or a data source at all, just to get us a bit warmed up. So let's just head into some code to see what GraphQL is and what we can do with it. Okay, so this is essentially an empty ASP.NET Core application. The one thing I put in here is a Hot Chocolate ASP.NET Core package. And we are using Preview 6 for this. Okay, so the package or the application at this instance is completely empty. There's nothing in there. It's just the default setup. Our server says hello if you start it, and there's nothing more to it. So what we want to do is put in a simple book example, so a simple GraphQL API that exposes a book, just to get us started. So GraphQL is really built around APIs. So if you look into what is GraphQL, it's a query language for your API. So in order to put GraphQL into some server of yours, you need some API. So let's start by creating a little model that represents our API. So for this, we just create a book CS, which is our model. And I already prepared a little snippet here. We have a book, which has a title and an author. Very basic. And the next thing in GraphQL is the way we want to query it. In GraphQL, we have basically three kinds of operations we can do. We can query something, which is a side effect-free read on our data. Or we can change some data, which causes side effects to our backend, and is called a mutation. So it's basically the put, post, patch, whatever you do with get, with REST, not with get. So in our example, we just want to read our data, so we want to query it. So we will just create a query.cs. And I already prepared this as well. So we do a basic class here, which is called query, and has one method, which returns a book. It's called getBook. And these methods here are actually called resolver in GraphQL. They resolve data. They resolve these edges through which we can fetch data. Okay, so basically we have the basis of our server set up. We just need to tell our configuration how to put these things together. For this, we use a simple dependency injection here. So we can say services at GraphQL server, and I'm just seeing that my packages are not yet restored. So let's do that. And again, say services, and then add GraphQL server. And the next thing is that we need to tell our GraphQL server what is the root query type. So we say add query type, then we just say query. And with that, our GraphQL server is actually set up, and we can host it. So for hosting it, we use the endpoints API from Microsoft ASP.NET Core, and just say map GraphQL instead of map get. And let's put that on the root, because by default, GraphQL would be put on the subpath GraphQL. But in our case, so we can just start it and directly get feedback. Let's put it on the root. Okay, and now let me just get in my browser window. Oh, there's already something in there. When I open now my endpoint here, I get this nice GraphQL IDE, which is called Banana Cake Pop. It's one of our tools that we built. And it helps you explore a GraphQL API. We can already see here on the left-hand side that our endpoint has a type query. And we could drill in here and then can see that our query type has one field book. And I can drill further in, and I can see that it actually has a title and an author.
Michael, are you able to zoom this a little bit?
Yes, I'm like this.
Looks good, thanks.
Okay.
So just to be clear on what just happened, the Banana Cake Pop, awesome name by the way. What you did is connect to that super minimal server that you just saw, and it kind of discovered the schema, right? Discovered what you defined on the server side, that book thing.
Yeah. So essentially, if I go to that endpoint here, which is my server, I get Banana Cake Pop, and that's because our middleware map GraphQL provides this UI for you. You can shut it off if you don't want it, but it's very good for development. And you can also embed it in, like if you go to the GitHub GraphQL API, they have embedded a similar tool into their documentation, for instance, so that users can try out your API or explore your API. And that's actually what we can do here in our schema browser, explore what our API provides. In this instance, we have a query root type, and we just have the field book. But remember, when I put together this query type, I wrote get book. what we do there is essentially we apply the GraphQL best practices onto or the best practices regarding naming on your API, and essentially remove the get, because in GraphQL we would say book or book by ID or something like that. So we remove all the parts from the method names, like async and things that we wouldn't want to expose in our GraphQL API. Okay, so let's go back in our query window. And here I can now write a GraphQL query. Because GraphQL is not like REST, where I have endpoints which represent resources. In GraphQL, I, the user, actually drive what data I want. And that's one of the biggest advantages with GraphQL. So I can just start typing here a GraphQL query, selecting my fields here. I get IntelliSense because my GraphQL server tells me what fields are there, tells me what symbols are available. And I essentially can then drill in. For instance, get the title, get the author. And when I now execute that, I get the response from my backend back. And that closely aligns with the request. So it puts me in control of how my data is structured. I could also say, I don't want author. And I actually want the book title to be called name. And then send that back in, and then the structure has changed like I want it to be. Okay, so that's a basic idea about GraphQL. You can fetch data, and you define the interface between your application or your component and the backend. So that's a bit different than if you think about things like gRPC or REST, where the interface is defined already by the backend engineer.
Yeah, it's worth stressing that what you just showed, like the last part, you're selecting exactly, you're projecting, to use database terminology, exactly the fields that you want. So that means that your client doesn't transfer any data over the network that it doesn't need to, right? It selects exactly the things that it wants, which is very good.
That's exactly what happens.
Like in a classical REST kind of thing, you go to your URL and then you get whatever a JSON document, and it contains all those fields, whether you needed them or not. And sometimes you see like a layer build that allows you to filter fields, but normally it's not like this. So this is very nice. Yeah,
and that's the first misconception that happens when people think, especially in the .NET ecosystem, isn't that what OData does? And it's kind of different, because GraphQL is more a projection API. So essentially a selector of your business API, whereas OData has this filter logic, is very cramped into the URI. So it's a bit a different approach, and it does different things. Okay, let's dive in a bit deeper, because this actually, when we can do projections and stuff like that, is a good fit if you have an entity framework integration in your application, because you could just hook that up into a hot chocolate, and we would allow you to drill into your data. So for this, let me just close this window, and then we can drill into the next demo. As I said, this one was just to get you started. The next one, let me just notch that up. Close all. Yeah, that should be maybe one bigger. Okay. So this example starts where we left off with our old example. Essentially, we have a query type that has a static return of a book. But that is not useful to us. Often we have this DB context around, and I have put one in here already. And that exposes now a book and an author model. And these are connected with each other. So when I drill into the book, I can get to the author. And when I'm in the author, I actually can drill into the book. So a typical DB context, very simple just to get into this topic. And ideally, I want to expose that in a controlled way. I don't want to just expose my full DB context. I want to be in control, and that's one of the key things in GraphQL. You want to be explicit what you expose, and you want to be explicit about what you are able to query from a user perspective. So the first thing we want to do in our example now is put in a DB context here. And that's very simple, because we can just say add DB context. And then we have a scope DB context per request. We get a context, and we need to operate on this context and do something with that. And typically, people build with this unit of work pattern around entity framework and have some repository logic around it and stuff like that. Okay, with this in place, we actually want to rewrite our query. So we could go into our query here, just remove this resolver. We learned this is a resolver, and put in a new getBooks resolver that actually gets injected the books context here. So Hot Chocolate provides something that is called method level injection. That means you can inject the dependency that you need for a data resolver into the resolver as a parameter. That is useful to tell the execution engine that we need these and that resources for this resolver. It can become cumbersome when you have always the same dependency for all the resolvers in your class. So you can do that on the field, which is good if you have variations there, but you also can do that on the constructor level. Okay. With this, actually, our resolver is set up. It would work right out of the box like that. And let's just start it and see how we fail with that, because it's not going to work fully. I'm doing a watch run so we can iterate on the code. And again, it opens up in this in the wrong browser. Okay. Okay, so our schema actually is a bit changed now. Let's have a look. Let me refresh. Oh, it's still on the old endpoint, GraphQL. Yeah. So now we have here our new books resolver, or new books field. I can drill into that. And I already can see that books is no longer a single book, but an array of books. And these exclamation marks here actually tell me that the book can never be null in that array, and the array will also never be null. So in GraphQL, the nullability concept is reversed. So by default, types are nullable, and you have to tell the type that it's non-nullable. So it's a bit different than in C#. Essentially, in C#, we put the question mark there and tell somebody that it's nullable, where in GraphQL, you tell people that it's non-nullable, so reversed. Okay, but we can already see we just put this new DB context in there. We just hooked it up, very simple. And we already can see that we have the full data structure here. We can drill in, we have the book ID here, we have the author here, we can drill into the author. Let me make that bigger. And go on for an infinite loop, because author goes in books again, and yeah, you get the idea. Okay, but we can also already query that. At least I hope so. Let's see.
Demo catastrophe.
So I could query that and already get data, and I didn't do a lot. But actually, it doesn't work fully, because there are two things around entity frameworks that are special. So first, our resolver understands that there is something like a queryable that you can execute. But if we want to drill into authors, for instance, then we get null, because at the moment, it doesn't understand that we can project into these things. The second thing is that Entity Framework actually is single-threaded or is not thread-safe. And that's by design. I mean, it's using the unit of work pattern, and it would just mess up the context. But GraphQL by nature is optimized for fetching in parallel. When GraphQL sees this query, it thinks, okay, there are two data fetching, two data fetches we can do here, and we just could parallelize them and fetch them in parallel, which is not so good for Entity Framework. Okay, but there is an easy solution for that, because Hot Chocolate has a query plan. So every time we execute something, we can analyze that and build a special query plan that takes these things into account. So the first thing, let's care about our first problem. That's the projections. In order to do projections with Hot Chocolate, we kind of have to register on the schema that we want to be able to do projections with our data. So we can add the general projections support to our schema. And then we can go to our query and put a middleware on here, which is called use projection. And this middleware, it's like in ASP.NET Core middleware that wraps around this resolver here and adds functionality. And essentially rewrites the GraphQL query into an expression tree that is applied on this queryable here. Okay, and with that,
so is this use projection middleware specific to EF Core, or
no? It works actually with anything queryable.
Okay.
It works with anything
expression tree, right?
Yeah, it works with anything queryable, but we have some specific logic for Entity Framework in there that also knows about that that Entity Framework, for instance, has a toList async and stuff like that. So if we detect that that we have actually a DB context here, that this queryable is from a DB context, we have some little optimizations how we handle this. So if there is a standard queryable and for instance, we don't have a toList async. There are some other ways we look then. Does it implement async enumerable to get the data, or in the worst case, we do it? We spin that off as a task and do a synchronous toList on it. So there are things that we can detect with Entity Framework and then make the execution better. Okay, but the second problem here is that we kind of need to ensure or tell the execution engine that this is actually, that this specific resolver needs a serial execution. So I can just say this is a serial resolver. And then the execution makes sure that this resolver is always guaranteed to run alone. So there's no other data resolver. So there are other resolvers that are allowed, but only pure resolvers that don't do anything with other services.
So I have to be annoying. That's my job here. So I'm just going to have to ask, if I do want to do these two in parallel, I can still do that in EF Core by spinning up two different DB contexts, right?
Yeah, you can use then pooling, which we also support, which is great if you want to parallelize. Okay. We just discovered that most people build other services around EF Core, and then mostly don't inject here a DB context, but a repository. And then it's useful actually to have this synchronization possibility. If you go for performance, actually, then I would use add DB context with pooling together and pool actually the context. And then you have a much higher throughput.
Sure.
Yeah. I spiked an example of this where I injected the DB context factory and just spun up a new context using the factory.
Yes, and that's actually what we do with Hot Chocolate 11 at the moment. We force people to do that at the moment. Okay. Because it's actually better for performance, pooling the context and then reusing that memory that is lost otherwise.
Yeah. So like in parentheses, I was working a lot recently on context pooling and EF Core perf, and DB context pooling is important. Like if you want to reach a lot of throughput, if you're seriously doing a lot of throughput, DB context pooling can change your life. So yeah, it makes a lot of sense.
That's what I personally tell people. But there's a lot of folk around that really likes to build these repository patterns and really need this synchronization level. And you can do that.
Sure.
But we can see in the query plan, which you can request on a request, that you actually can also run that in parallel. And then we really get, so if I do performance testing, we actually use DB context pooling, because otherwise you create a context now, then you throw it away and throw all this precious memory away.
Yeah. Yes.
Okay, so let's dive in back. So we said this is serial, and we use projections here. And now my server should already be up again. And we can go back to our server here and just run that again. And then we get the query, and you see it's projected. And if we go here, you can already see that we have essentially two queries, because we will execute these root fields now serial, one after the other. But we have projected it correctly. We have a title here. We have the author ID here joined. So it's a proper SQL statement that has the minimal impact for the SQL machine.
I have to say that's a very short path to getting to like a query like this that works with a database. I'm very impressed.
Yeah, it's now with Hot Chocolate 12. It's really easy to get people that have a DB context that do entity framework. It's very easy to get them into GraphQL. And if you think about that, and that I think is one of the things I love about this integration now, is that it's just C#. You didn't even see that there is something specific to a GraphQL around it. You didn't have to care about the GraphQL types. You could just write plain C#. You can get more specific about GraphQL. We have Fluent APIs. You can build proper GraphQL types, but you don't have to. You have this very easy pass into that.
Yeah, that's important. I remember last time I was looking into it, there was a cliff of understanding GraphQL concepts, which you had to go through before you could reach like a minimal thing that was working, or at least to some extent. And this looks so much better. Really.
Yeah, we put a lot of work into that after feedback, and also after feedback from you guys. That it's now much easier to just hook that in, get your server running, and already be able to query things. And we even can do more here. Like we can, for instance, say, wouldn't it be great to write where clauses? I mean, GraphQL by default doesn't have a standard for doing where clauses or so, but wouldn't it be great to have something like that? And yes, it would be. And you could do that. We can just say, let's put another configuration in here. Let's allow filtering. So we can say allow filtering, and maybe we want to be also able to do sorting. So we can say add sorting, add filtering. And now I can opt into, and I can do this opt into each field. So I can say, in this field, I want to do filtering, allow filtering, use filtering, and
so you have these middleware for query operators, we can call them, right?
Yes.
Which basically will take a GraphQL syntax for filtering and sorting and translate them into the queryable kind of stuff.
Yeah, it translates that, and then the entity framework actually translates it further into the SQL kind of stuff. So it's essentially rewriting queries in a pipeline, which is kind of nice how it works. And this middleware actually puts you in control. You don't have to offer this support, because it could be bad to allow somebody to arbitrarily filter into things. That's why you also can specify which fields you want to allow to filter on, which operations you want to filter on. So you could really specify even on the operation level, isn't equals allowed, isn't contains allowed, and things like that.
So in the use filtering, I can say I'm allowing filtering on this field, but not on that field, and this kind of stuff, right?
Yeah, you can
That's what you're saying.
Exactly. You can essentially create something like this: book filter input type, which is a filter input type. Let's see. Yeah, then we opt into that, and then we say we want to have a filter input type of this book here. Then we could define what's a Fluent API. What you are allowed to do. Like I could drill in and say allow end combinations, allow OR combinations, or allow this field.
I see. So just for our audience who may not be getting, for people who may not be getting this, we are potentially exposing an endpoint here to the internet, right? So yes. It means that if I just allowed everything, like everything, all the operators, then basically I'm allowing anybody to execute arbitrary, let's say, link queries, if we're coming from that world, any sort of query, right, against my database, which is potentially a very big problem, right? We don't want to allow that.
Exactly, and that's why I'm cautioning. So it's good to have that capability that you just plug on a filter and then it just filters the stuff. But it's on the other hand very dangerous, and you have to be in control as a user of what you want to actually allow the people to filter. It can be useful, like if we are, for instance, building this books API where we can then search for the author or something like this. This could be useful. But we might not want to allow arbitrary likes or.
Absolutely.
Yeah. So there's a lot.
This is born to be like a denial of service attack, like very.
Exactly. Exactly.
Agreed.
So, but again, you have this very easy pass into. You put a few attributes on there, or you use our Fluent API. We also offer a Fluent API, and then you also can use that as well. So with this. Our API is rewritten, actually. We can head back into our API here. Just refresh the schema. Let's have a look at our books and our books field, because we now actually have a couple of more inputs. Yeah, there you can see that. This is our books field. And we now have here the arguments that we can pass into books. For instance, we can do these combinations, like we could query for a title. And when we query for a title, we have equals operation, non-equals operation, contains, and all the stuff that we automatically get because we didn't limit what we can do. So let me just get rid of that.
So just a question about the metadata you've added. That's not part of the GraphQL standard. That's something you add as a convention to make the query, or is it how GraphQL specs those types of queries?
So there is no standard for how you query it, but this is spec compliant because this are essentially GraphQL arguments. So GraphQL APIs can have arguments, and what we are doing there is essentially you use input objects, which defines the inputs for these arguments here, to essentially build up a query aware syntax. And there are a couple of projects that started with that. So there's Hasura or Prisma and others that do such an approach to offer the user to query also SQL-like APIs, or to essentially represent filters. And we went along in a similar direction like Hasura, where it almost is like, if you know Mongo, it's very familiar how these APIs work. For instance, I could say I have a where, then create an object here, and then select the field on which I want to query. In this kind, I want to query for an author. And from the author, I maybe want to query for the name. You can see even object queries, deep object queries work. And then I might want to look if the name, for instance, yeah, Richter. Let's take him. Contains Richter. So a very simple query, but it allows already to not query just for the books, so for the top level, but also really drill into the data. Then I could just execute that. I get back my data here. And then I can see, okay, these are all books from Richter. It's 4th edition, 3rd edition, all the editions of his books.
Excellent book, by the way. I love CLR via C#.
Yeah, all the authors are good. By the way, also John Skeet.
Yes.
Yeah, and if I look at the query here, I can see that it already translated nicely into my SQL query. So we translated into expressions, entity framework, then translated for us into SQL, which is very nice here with parameters even. So it's nice also for the backend as a parameterized statement. Okay. So this is nice. I could also order it. And if I now want to have something like paging, because we didn't care about that, I just could go further and say, let's put some paging on here. So it would essentially be just another attribute, use paging, and then we are done. So there's one more aspect around GraphQL here, because GraphQL is not only about translating databases. Actually, it's meant really for querying APIs. But GraphQL is also great as kind of a gateway technology. And what I mean with that is, so we are not only, often we not only want to query data from a DB context, but we might want to combine that with other data. So in our concrete example, we might want to mix in maybe book descriptions. Maybe there's on the internet some description about the book, and I'm emulating the internet here with a JSON file that is here on my local disk, which maybe has some description of 2 of our books. And I want to kind of mix that into my graph in a natural way, not in a way where I have like a separate type or something like that. I really want to mix that in. I essentially want to create here on my book model another field, but I really don't want to mess up with my models in entity framework. So how am I going to do that? So we have something in Hot Chocolate, or that's also something you have in GraphQL. You can extend types. And that means I can create a new class here. And let's call it book details. Okay. Let's see, do I have a snippet? Yes. I should have actually a namespace. Let me just grab that. And then we go into that back. Book details. Where is it? Yeah. Okay. Let's just get the class. And what I can do with this, I can actually tell this class that it extends the book type that we already have. So this is GraphQL specific. So I'm extending this book type with new resolvers to fetch data from somewhere else. And in this case, we are using something called a data loader. And the data loader is a way to now fetch from this other data source in a very efficient way. And let me just demonstrate that, because it's a wild concept to explain, but it's actually very easy. So for this, let me introduce another class here, which I call book by description data loader. And this is a very GraphQL specific, or the data loader actually is not was not created by Facebook specifically for GraphQL, but for the specific problem to batch data. Import all the imports that here I'm missing. And we walk through that code. Okay, so a data loader allows me to intercept calls to a data source and then essentially wait until the execution engine tells the data loader to actually fetch the data in one go. And that is useful because I'm extending now the books node in my graph. And I might have 5,000 books. And each of these books is calling one specific resolver to get now data from another data source, and that would lead to 1,000 calls to the other system. And what the data loader does is essentially collecting all these calls, and then delegating them in one go. In this case, I'm just reading my JSON file, and then I'm getting here all the keys for which I shall get the descriptions, and then I'm executing that in one go. That works essentially. Yeah.
Sorry, I'm interrupting again.
Always. No, go ahead.
What you just described also reminds me a little bit of like the lazy loading problem in the N+1, where you're executing like a database round trip for everything that you want rather than doing just one go. So the concepts again are very similar, and it's interesting to see that.
Yes, that's exactly, and that's exactly the term. So this is to avoid the N+1 problem that you would get in a graph when you fetch for each node in parallel. And the execution engine essentially uses this data loader by injecting here the batch scheduler. And what the data loader essentially does under the hood is scheduling to the execution engine that there is something to be executed for a specific resolver, and the execution engine will just go on executing everything until there's nothing more to execute but these batches. Okay, so let's fill that in here with some more things. So in order to get the book details now, we want to get the description. So we put in a new resolver in our book details, which is called description. And this will be merged into our GraphQL type. We'll see that in a bit. And in our resolver, we want to have the book type. So essentially the model that we are extending in order to fetch from this data loader here. Okay, there's one more thing to do. Because we want to hint the execution engine that we actually always need this ID to fetch the data, because we are injecting here book, and we need to essentially hint the execution engine that we actually need from book only the ID. So with the next few previews, we are actually using source generator, and we'll see that you're using here ID, and then you don't have to do anything. But there's always the way I'm doing it now to override this and tell the execution engine, actually, I need the ID. So what I'm going to do here is just introducing something called public int get ID. And this ID actually gets the book. And from the book, the ID. Okay, this is not spectacular at this moment, but I'm also putting an is projected on it. And this tells the execution engine that I'm actually projecting this guy here. I need it always when I run this. Okay, with this, let's just hook that together. Type extension. And then I'm telling here book details. And then we .NET Watch run it again. And let's refresh my graph. Okay. And let's write a new query. So I can now drill into my books here. And wait, there's something wrong. Oops. Yes. And I now have this description here. And if I execute this description, I get the description for the nodes I have the description. But in order to understand what actually happens underneath, we can go into our headers and tell the GraphQL engine to also emit the query plan that we have underneath. So we just say at the header GraphQL query plan, and then the execution engine will actually emit here the query plan. And we can see now also all the serial stuff, like the execution engine in this instance has here some serial resolvers that have to be executed one by one. That is our books. That is our books resolver here that accesses our scoped DB context. And then we can see that we have here a parallel node, which actually consists on our internally projected data. This is a book ID that we project because we know we need it for description. So we build internally the expression tree to get this data because we know we need that for description. So this is essentially how you can merge multiple data sources, and we rewrite the query plan beneath to get the data, even if you're not actively requesting it, for the resolvers that need that. And that works very good also with other databases, like we are also in version 12 introducing Neo4j support for graph database, and you could merge and match that with Entity Framework, and the query plans actually would fetch. When you're fetching from both databases, we would look at overlaps, like is it cheaper to get maybe this ID from the other data source, even though you requested it from Entity Framework, because we know you have it in Neo4j, or we know you have it in Entity Framework. Like the query plans really look into how to best fetch the data. Okay. That was a lot.
So your simple looking JSON response behind the scenes actually kind of, can I use the word stitching here? Stitch together like two completely different data sources. One of them is Entity Framework, and another one was some JSON file on disk.
Yes.
And we don't even know this. This is just a detail in the backend, right?
Yeah, and the query plan can even do more. It could lift, like it could write an arbitrary query to fetch the data and then inject that actually in the resolvers, even though, yeah, like I said, it looks at overlaps and things like that. So there are quite some optimizers in, and you can write your own optimizers to even go further into that. Yeah, it's essentially like a database query plan on top of databases, you could say.
Or other things, yeah.
Or other things in that instance.
Yeah.
Just one small thing here. We did this data loader. Where did I put it? There. And what I actually did is print out the fetches that we did, and we can see here. And then our request we did. We did a request. This is the SQL that just gets the ID. Then it's fed into the data loader, and the data loader gets in one go the descriptions for the nodes that I need to fetch, 1, 5, 2, 6, and so on. That's actually just how that works. So we essentially have two batches. Get it from the SQL, and then batch it from our JSON file.
Split query for GraphQL.
Yeah. Yeah, and that's actually also one of the concepts that we do, like splitting, because in some cases it's not good to fetch everything from in one go from a data source. Sometimes you have to break up the graphs. Yeah, but essentially split queries. Okay, so that is demo 2 behind us. Let's head into real-time data. And the third demo, also with a heavy Entity Framework context. Okay, so this is essentially the same API, a bit more types now in there, and a bit rewritten. I said we can also use constructor injections with the Entity Framework. If it's scoped, for instance, it's not so good if you are using a pooled factory approach. If you have a pooled DB context with the factory, then I would always use resolver injection, because then we inject you the right DB context in the right resolver. So we will get them from the pool. We will inject them to you so that we can ideally parallelize the data fetching here. But in this instance, we are using the serial approach. We inject it here in the constructor. If you inject it in the constructor, you also need to in turn register your query type as a scoped instance so that it's gotten rid of after the request. The second thing we did here is that we actually modified the default options and said that we, by default, everything is serial, except if we say otherwise, that it's parallel. So you can also reverse the logic. Like I showed you the logic where we are parallel by default, but you could also turn it around and then be serial by default and just tell, okay, this resolver actually can be executed in parallel. Okay, so this is our basic setup here. Let's just have a look at how it looks like. .NET Run. And then think about what we can make real time. Okay, already got the new schema. Yeah. Okay. So we now have not only query types. Query types, I said, are side effect reads. We can just read data, and that actually can be parallelized however you want. At least in theory. And then we have something like mutations, which are causing side effects. So mutations are by default, by the GraphQL spec, are serialized. Okay, so when we think about real time, it's often caused by a mutation. So a mutation is done like we are adding an author. And then because we add an author, we might want to raise an event which sends down the author maybe. And that is useful for reactive client applications where we just can subscribe to the data. And then we kind of say, okay, every time the book changes, I want to update my UI components. So tell me when the author of the book changes, and then we do something. There is also another concept which is called live, and live works actually on the queries, and that's more complicated. I will not go into that today, but essentially you can also say, okay, I have this query, this is a live query, and then the server will send down the changes that happen to the values of the query. So every time something changes from the values of the actual query, it will emit these changes down to the server. For this, you need a reactive data store in many cases, or it's not that efficient. But we are looking at something that is called subscription, and that is the easier approach when you get started with GraphQL. Okay, what I want to do is we have this add book here. And we want to trigger an event every time we add a new book, like on book released. Every time there's a new book added to our store, we want to raise an event, and then we can use that in our UI to display that book. Okay, let's go at it. What we already know is that we have these classes, query, mutation. These are classes and represent our root types. And subscription is no different. That means we can just add a new root type, which is called subscription. Let me just move that down here. And it's actually the same like with the query. So let me just copy that and rename it so we are a bit faster. Okay. And that is essentially our root type that represents our events. So how do events work? In GraphQL, events are the same like queries. It's a resolver. So we essentially have something like an on book released, which is our resolver. But this resolver is special because it can receive payload. So it's only executed when it receives a trigger. And this trigger can or will always carry an event message like a bus system, or behind that is actually a pub subsystem. And then we will execute the query beneath that resolver. So every time a book is released or a book is added, this resolver will be triggered and will receive the book that was actually added to our store. There are two more attributes we have to put on that. One attribute that actually signals that we are a subscribe resolver, and this signals to the system that we need to subscribe to a pub subsystem. And we also have to provide the topic. In this case, I'm making it very simple. I'm just writing topic on the method, and that makes the method the topic. But we could also put it on an argument that is passed into the resolver, and then this argument becomes the topic, or we can also generate the topics more dynamically even. But in this case, let's keep it simple. Subscribe, topic, and event message, and we are done. Our real-time event is now working. It's there. But we still need to trigger it from somewhere. And I said mutations. So when we add actually a book here to our DB context, after we have saved it to the database, we want to trigger the event. And I've learned from one of your last episodes there are even triggers in Entity Framework. So you could put that code even in these on before save triggers, and then make that more transparent here. Okay, so let's put it, in this case, in our resolver. We can just inject it. It's just a standard service. So we say service. And then we inject an iTopic event sender. Okay. So with this event sender, we can now trigger events. And that is now quite easy. Let's see. I already have a template for that. We just say event sender send async. And then I use the topic here. And I said we are using the method name at the moment as a topic. And we are sending along the book that we already have created. With that, our event is triggered every time our resolver is essentially triggered from a query. Last but not least, we need to do a bit of configuration in our startup again. So we go here and we say that we now want real-time data. So we say add in-memory subscriptions. We also provide subscriptions over Redis, and you could also use other providers to do that. So if you want Redis, you can put the Hot Chocolate Redis package in, and then you can say add Redis subscriptions. But for a single machine and or a developed machine, add in-memory subscriptions is sufficient enough. Okay, with this we have now our pub subsystems put in. We need also our subscription type in. And then we have gone full circle. We have everything in place. We already have used WebSockets. It's important to have that here, otherwise the real-time events will not work. Okay, and with that, let's run it again. Go to our banana cake pop. Let me take the old version here to put it side by side to our newer one, and then we do some real-time eventing. Okay. So this is our schema. And we essentially can just create a mutation here, add book. Add book. And then we have wrong. Oh, that's wrong. Okay, add book. Send mutation. Okay. That kind of is wrong. Okay, let's take the other versions. Might be a bug in the in our new method. Okay, let me just close here everything and then put the UI in again. Okay, so here we have our schema, and I'm writing a mutation. Add book, input. That's what I wanted. And then I have the title here, hello. And I have an author ID. Maybe it's John Skeet who wrote his first hello book. And then we get the book back as a response, and we just print out the ID in our new from our new book entity. So on the other side, I will use subscription, and I hope this works out better than I feel there. And maybe I just want to, every time a book is released, a book is added, I just want to print out the title here. Let's try that. Okay, I fired that up. It actually works like a query. So subscriptions are no different than, at least from writing that query. The syntax is the same. I can start that. And now it's listening. You see this donut here circling. So it's listening for incoming messages. And when I now write this message here, it should actually have received that. It is our preview properly. So I was brave to just, so let's swap that around. I know it works actually with this.
Every session has at least one demo bug, so this is yours.
Yeah. Yeah, it's really, it's the first usable bit that we have of version 12, but it just fitted so well in this episode that I went, and you can see that real-time data. So we created it here. Now we see it here. I can also change it. Hello world. And then we send it, and we get the new title here. So that's real-time data, also very simple to do with GraphQL. And I think we have our hour. Otherwise, I could have shown you how to integrate that in Blazor, but it takes too long.
Jeremy, can we reserve like another 2 hours here?
Let me go to the, whoa, I don't need to be that big. Yeah, we can go to the calendar and do that. Blazor is awesome, by the way. We should have another episode that's just GraphQL and Blazor.
Yeah, because when you want to take it full circle, you take that to Blazor, and then you have all this reactiveness and can use that in a Blazor UI.
Which also brings up the question of using GraphQL as a client in .NET, which unfortunately we're probably not going to do now in the next 2 minutes. So
no, I prepared it here. It's demo 4, but yes, it would take up too much time.
Of course.
But it's also very simple. It integrates very well, and we already released a preview for Visual Studio. So we now have language support in Visual Studio for GraphQL. So if you're on Windows, you have Visual Studio, just install the Strawberry Shake plugin into your Visual Studio, and you have full GraphQL support with IntelliSense and stuff like that, which makes it very easy to create clients.
Very nice.
Extremely awesome.
Great.
Yeah, it's come a long way. I actually have a app that I've been spiking just to learn more about GraphQL, and I think I was on an older version of Hot Chocolate that didn't have all this support for Entity Framework, so I'm going to revisit that and refresh it.
Yeah, that's one of the big changes we did to version 12, because people in .NET love Entity Framework, and we got so much feedback to make it simpler, to make it better. And now with version 12, it really starts to be very nice. So it's still, you saw a few bugs. So we have some time until the end of June where we want to release that. So in the next months, we will add stability to that.
Sounds great. Thank you so much for coming on. That was incredible. I loved the session, loved the capabilities coming out. We have the link to the repo in the show notes. So anyone interested in reaching out, head there. And we probably will have you on again sometime, I'm sure. It's always a pleasure to speak with you, Michael.
I think so.
Thanks for coming on. And thank you, our listeners, for taking the time to both watch this, and for those of you who are on the live show for participating. We appreciate you, and we will see you shortly. And I'm going to find my magic goodbye screen, and that's a wrap.